So there's a type of factoring we didn't talk about yesterday, and it doesn't fit your normal mold. You can actually make it fit your normal mold, but I think it's easier if we just don't. So you're used to quadratics that look like this. By now you've done, I would say, literally 50 or 60 of these. So when you see a factoring problem like this, you just hop in instinctively and you just build your double shells, you put in your X's, you do your signs, blah, blah, blah. But there's also another type of quadratic that pops up. And what's unique about a quadratic, say, like this, is that you'll notice very quickly notice that there's no number right here. So I've kind of gone back and forth over the decades as to like, do I put a 0 there and just show them how to do this? And it is possible that way, but I think it's pretty bad practice. So what I want to show you instead is like number 10, when you get a quadratic that's missing its last term, you'll see if you haven't gotten there, when you get to problem 10, the -2's will cancel out and you'll get a quadratic with no number at the back. So when this happens, you have to employ a special type of factoring. That's GCF. You guys all know, I think that stands for greatest common factor. And the way you approach factoring in a case like this to make your life a little easier is you just look at these two terms. So one of the terms is x squared, and one of the terms is 5x. And you ask yourself, what do those have in common? What, say again? Yeah. The x, right. So if you think about it, like if I mean, in case anyone gets confused on this, I want to make this so that you cannot get confused. If I wrote this problem over again as x squared plus 5x, I mean, you literally can't not see that there's an x in this one and there's an x in this one, right? We call that a common factor. So when we factor, what we do is we essentially do the distributive property in reverse. We call that GCF factoring. And so if I take that x and I actually undistribute it out, like it's not really a word, but it totally should be undistribute. If I undistribute the x and I like pull it out is what we say. If I take that x and I put it out front and I rebuild, what would the x have to distribute through to remake x squared plus 5x? Like what would have to go right here where that arrow's pointing? No, I just need an x right there because what is x times x? Aha, jackpot, x squared. So I'm basically just reconstructing the problem by doing the distributive property backwards. And then I put the plus here, and what would have to go right here where the other arrow's at? A 5. So this is a successful factoring, and it doesn't look anything like the factoring that you've done before, but it's actually really, really easy. Let's practice it again. Let's say I had m squared minus 4m. Again, it's a weird one, isn't it? There's no number at the end, but after today, you're like, I like these. These are actually easier. So what can I pull out of both of these terms? So I put the m out front and I undistribute. What would have to go in the first spot? What would make that equal m squared is m. And then I copy the minus sign. And what would have to go in the second spot? A 4. So you might wonder, like, well, where's this headed? Well, let's say I took something like this and I said, like, okay, I have y squared plus 7y equals 0. So this isn't problem 10. I kind of want to let you do that by yourself, but this is similar to problem 10. So again, it's a weird one. What would I pull out of both terms? Good. And then what's left? Y plus 7. So here's a new thing. I hope this doesn't lose you here because this actually should be really, really easy, but I never know. The two factors aren't what you're used to. You're used to like parentheses, like x plus 3 parentheses x minus 5. But it's actually pretty simple. This is like one of your parentheses sets. It is a factor. And this question, I've asked it 200 times and it always feels weird. What could you put in place of y to make what I have circled in red equal 0? 0. One of your answers is 0 because 0 is the only number that if you put it in my little red circle thing, it's the only number that can literally make that red circle factor equal 0. If you put in 1 or anything else, it's not. Like you need that. What I have circled in red is called a factor, and you need it to equal 0. What makes my blue circled factor equal 0? Just like you're used to, -7. Okay, let's go again. Let's say I got to 1 and it said k squared minus 3k equals 0. What can you pull out of both terms? Leaving behind what? K minus 3. And again, what makes, sorry to ask you this again, but this time no one will miss this. What makes this red one equal 0? Literally just 0. And what makes my blue one equal 0? So my answers are 0. You could make a case here and say, so will problems like this always have an answer of 0? Yep, 100% of the time. Got it? Right. It doesn't. So like let's say we had like 5y squared minus 10y. Great question. So let's think a little bit bigger picture this time. This time, what can I get out of this red term and this blue term? Do a little bit better than just saying y this time. What can you get out of both of those? You can get a 5 because they're both divisible by 5, and you can pull the y. But if you just always remember, undistribute, 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 it's backwards distribution. Now, what goes there? Just a y, because you have to always check and say, will that multiplication problem equal? Yep. And then what goes in this second spot? 2. So I ask you again, what makes this that I'm circling now in red right now, what makes that equal 0? 0. It's the only thing. If you say 5 times what number, I need you to equal 0. And if y equals 0, that is the only way to make that happen. And what makes my green one equal 0? There's your answer. So I say again, in problems like this, will one of the answers always be 0? Yes, literally always. Okay. Does that make any sense at all? That should help you immensely with problem number 10. If not, then yeah. Because these are, were you here yesterday? So these are quadratic equations, and what we're looking for is we need 2 different numbers that solve the equation. And a quadratic equation, so let's practice again. Let's say I had 3y squared minus y equals 0. I can tell you this right now, the fact that it's a quadratic, you see I'm circling the number 2. If it's a y squared equation or an x squared, that exponent will tell you how many answers you need to go find. So because it's a degree 2, that's what we talked about at the very beginning of the lesson yesterday, that exponent will match the number of answers. So for this whole worksheet, we're searching for 2 answers. So let's factor. What can you get out of this and this? What do they both have? They both have a y. And now let's undistribute and rebuild. So what goes in this first blank right here? If I put y there, I ask you, if you multiply this by this, do you get 3y squared? You need a 3y, right? You just need to put there whatever you need to rebuild what was there before we started screwing around. And minus, and then what's going to go right here? Just ask yourself, y times what makes y? 1. So first off, before we move on and I actually answer your question, do you agree that if I took the math problem in this blue box and I multiplied it out like a problem we would have done back in September when we first met, if I just gave you the blue box and said distribute it, do you agree that you would get this? Let's check it. So follow my green arrow. What is y times 3y? 3y squared. Look, we made it. And what is, follow my yellow arrow now, what is y times -1? We made it. So now do you agree that the blue box and the blue oval literally are the same as each other? Okay, so the answers for this problem will be 0. That's one of them, and then I'll show you why this works. And then the other answer, like we learned yesterday from this one, is y equals 1/3. Now, you say, why are there two answers? Well, how is that possible? Well, let's take a look at the original problem. So the original problem is 3 times y squared minus y equals 0. So if I'm going to claim that these red and green numbers down here are the answers, then they dang well better work. So let's check the red one first. If you put 0 right there and right there, what is 0 squared? And what is 3 times 0? Okay, minus, and then if I put 0 in place of this other y, that of course just becomes a 0. And what's 0 minus 0? And 0, last I checked, does equal 0. So you can agree that this is a solution, right? Okay, let's go check 1/3. And this is way harder for me to answer your question this time, for the record. But you're going to need to ride along with me. We got to do some basic skills stuff here. So here's the original problem again. So if I take the green number, 1/3, and I put it right there, you may have never done this before, but to square a fraction, which is what we have to do, because that's the answer we're checking to see if it's legit, you just square the top and square the bottom. So that's going to be 1 squared is 1, 3 squared is 9. Are you still with me? For real? And then I'm going to put minus, and then I'm going to replace this y also with a 1/3, because that's what I'm checking. Now, can you help me with some math here? What is 3 times 1/9? Nope. Oh, she said 27, so I just... So you have to take your 3, which is 3 over 1, and multiply it by 1/9. And then do you see how you get 3 times 1 is 3, and 1 times 9 is 9? And then do you also agree that if we reduce 1/9, that we get 1/3, or 3/9? If we reduce 3/9, we get 1/3. So I can now say that what I have in the yellow box equals 1/3, because that was me after I multiplied it across and then reduced it back to 1/3. And what is 1/3 minus 1/3? And 0 equals 0. So we have another solution. The whole meat and potatoes of yesterday's lesson is that obviously we're factoring and all that, but when you find x equals 2 and x equals 5, they each work. Like they each, if you put them back in the original problem, make it true.
Okay, it should be.
Where's my, are you talking about down here? No, you got to remember that the factors that we get, if you have a factor that says 3y minus 1, you need that to equal 0. That's really what this is all about. And then you see that we would have to add 1 across to both sides to give us 3y equals positive 1. And that's where the positive 1/3 comes from. You always got to remember to switch your sign. So like if, let's say I did a factoring problem, just some random problem, and I got like 4x minus 3 times 2x plus 5. So pretty hard factoring problem, but let's say we grunted it out and we got to here. The answer that we get from this one would be positive 3/4. And then the answer that we get from this one would be negative 5/2. Got to always remember to switch those signs because you're trying to make what's inside the parentheses equal 0. Y'all good?